Hello, so today we are going to do this problem called swapping nodes in a linked list. So what the problem says here is that we get the head of a linked list and an integer k, and we want to return the head of the linked list after swapping the values of the kth node and kth node from the beginning and the values of the kth node from the end, right? So the kth node, so here for example k equal to 2, so the second row of the from the beginning and the second row from the end, we want to replace to swap the values. So 4 here and then 2 here. For the second example, 5, we want to swap the fifth from the beginning. So 1, 2, 3, 4, 5, right? This one here, and then here 1, 2, 3, 4, 5. This one. So we swap these two, right? Yeah, so that's the idea. Let's see how we can solve it. Definitely the easiest solution of all is just to use extra space and just transform the linked list into an array here, and then swap the values. In an array it's easier to find the positions k from the start and k from the end, and then once you swap, reconstruct the linked list, right? So that's very easier, but it's not a very clever solution that uses pointers. But let's just quickly go over it, and then we can go over the more clever solution, right? So here it is. What we do is just we create an array, right? We go through the linked list. So every time we do node.next, and then we add the values to the array. And once we do that, we take since the numbering here is 1 indexed. We want to subtract it by 1 because array is 0 indexed. And this in Python just means the length of the array minus k, right? Same thing here. This just means the length of array minus k. So basically just the kth from the end. And so we swap the two values, k's from the start and k from the end. And then we recreate the linked list. Basically going through the array, and each time the node.next would be the node with that value. And we do node.next. The only trick we are doing here is that to not need to do any special condition here for the head, we just create a dummy node, and that dummy node will point to the head, and we can return just the dummy node.next, and that will give us the head. So this is a pretty straightforward solution, but we can actually do better than this. We can just do it with pointers on the linked list. So let's see how to do that. Okay, so the idea for this solution is that we can move a pointer all the way to the k places. So we move one pointer, let's call it n1. So we move n1 to, basically first we have a pointer, right, to k position, and let's call that the first node that we want, so the kth one. So this would be n1. And then once we reach this, we'll place another pointer on the head, right? So once k equal to k is reached, right, we'll place a node n2 at the head. And then we keep traversing until we reach the end using pointer p here. But what this will tell us, basically, let's say k equal to 3, right? So we place our pointer, we keep advancing our pointer until it reaches k equal to 3, which is here. And so we mark this as the first node that we want to swap. And then we place another node here, n2. And now we keep advancing the pointer until p is at the end. When p is at the end, n2 would be just at the end minus k, right? Why? Because the gap between p and here is k, right? And so as we move both at the same time, right, as we move both n1 and p on each iteration at the same time, when p reaches the end, the gap will be maintained because we will still move each of them by one node each time. So the gap will be maintained. So once the p is at the end, the gap is k, and that's exactly what it means to be k from the end, right? So that's the idea. Let's see how we can apply it to this example. So let's do it here. So k would be equal to 3, right? So what we can do is keep decrementing k until we reach 0, we stop, right? So first we start out just with p, So first we have p here. We advance, k become equal to 2. And then we advance again, k equal to 1. So k equal to 3, and then here we subtract is equal to 2. We subtract here is equal to 1. We subtract here is equal to 0, and so we stop here. And so this is n1. We mark n1 here. And now we put n2 here in the head. And now we advance both, right? So what this tells us first is, let's mark this down. So if once k is equal to 0, we want to mark n1 as p, and we want to mark n2 as the head. And this is for a while loop, while p hasn't reached the end. And of course, on each iteration, we want to advance p, right? But once we have n2, right, once we set it here, we want to keep advancing it along with p. So if n2 here, we want to advance it. If we had set it before we reach the position k, we don't want to care about the n2 because we want to maintain the gap of k. So here, that next, if it was set already, which means we have reached k, right? Okay, so now we advance both at the same time, right? So the first one, we put n2 here, we put p here. So now k is equal to -1. Yeah, of course, I forgot to do this here. We need to decrement k each time. And then we advance n2 again. So n2 is here, p is here, k equal to -2. We advance n2 again. P is here, k equal to -3. K doesn't matter really right now because once it reaches 0, we don't care. So just imagine we decrement it each time. Okay, so now we advance again, and 2, we have p here, and 2, we have p here. And then we reach the end. And now our kth node, kth from the end is 6. And this one is 3, so we swap the values here. So this would be 6, this would be 3, and we can say here that we just swap the values, right? So this would be n.val with n2.val, and we swap. In Python, you can do it in one iteration. In one line. For other languages, you can use a temp variable. Yeah, and that's pretty much it, right? And so, yeah, this is a nice trick to obtain kth from the end while just traversing the linked list. In terms of time complexity, we are just doing one traversal to the linked list, so it's O(n) time. For space, we are not doing any extra space here, so O(n). Yeah, so that's pretty much it for this problem. Let's code this and make sure it passes test cases. Okay, so here's the code for the solution we just saw. So we mark P first at the head of the linked list. And then we have two nodes, N1 and N2. And then we keep traversing until we reach the end. And each time we decrement K. And once K reaches 0, we set N1 to the pointer and N2 to the head. And then we can also do this, by the way, here. It doesn't have to be at the end, at the front. And so we advance P each time. And once we set N2, we want to keep advancing it along with P. And then at the end, once we reach here, we know that N1 is at the kth position and N2 is at the kth position from the end. And so we swap the values and then we return the head of the linked list. So pretty straightforward there. Let's run this. Okay, actually looks like, so this would be N2, N1. We just want this to be done here. Okay, yeah, sorry. It has to be done before we change it. Okay, so let's submit. Okay, so that passes test cases. Yeah, so that's pretty much it for this problem. Please like and subscribe and see you on the next one. Bye.